Namaskar. Hello everyone. RVD here and welcome to my YouTube channel. In this video, we are going to go for the next topic of my playlist, a course on C programming, where the C programming is simplified. And the topic is understanding quadratic equation. See, I am planning to take a program for solving quadratic equations. So my next video is going to be on that, where I'm going to implement. But what I want is, before we implement the quadratic equation program, you should be clear about the concept. That what is quadratic equation, how do we take it, then what are the different formulae we are going to use, so that when the next video you will watch and I am going to implement there, you would be completely clear about the basics. Okay, so that's the reason I have created this video exclusively. So let us go ahead and try to understand. As usual, before that, I would quickly give you a kind of a subscription appeal. So if you have not subscribed my channel yet, do that please, and do spread it across to your friends. Okay, it's a good material I'm creating about C programming. So let me hear from you. Do watch my videos, like them, share them with your friends. Do post comments in comment section. Tell me how you feel about my videos, about my overall work. I'll be happy to get those feedback. So let's continue. So as I said, in this video, we'll be looking at what is the quadratic equation. So your quadratic equation is generally considered in a form, which we will be assuming from the user, that is ax square plus bx plus c, and that is obviously equal to 0. So what I'll be taking these three coefficients as input, a, b and c. Okay, so either they could be integer or they could be float. I'll be keeping them mostly as float, so that even if I want to give integer value, I can do that. Even if there are fractions required, even that can be done. But remember, this happens to be a quadratic equation only when the value of a is not 0. So a should not be equal to 0. So that's the first checking I'll be doing. You will see that in the program as well. I'll be first checking if a is 0. And I'll simply say it's not a quadratic equation and I can return. Okay. Otherwise, I'm going to go down and then I'm going to solve it. So if this becomes true, this will be the end of the program. Don't worry, I have not written syntax in here. So printf and all would be there. I'm just giving you an overview. So I hope you can understand that. So that is the checking whether it's a quadratic equation or not. Now, if it is a quadratic equation, I'll be using the values of a, b and c and applying the formulae. So let us go ahead and understand what these formulas are. So when I have a quadratic equation with me, I would say the roots or x or whatever you say is nothing but minus b plus or minus square root of b square minus 4ac upon 2a. Now this plus and minus obviously can tell you that there are two types of values here. It would be either positive or it could be negative. So now the types which I was talking about, they are dependent on the value of b square minus 4ac without square root obviously. So I would first calculate d, stands for delta. So calculate d equal to b square minus 4ac. Now based on this value of d, I have different types of roots. So if d is greater than 0, if the value of d is positive, roots are real and distinct. Okay, what will be the formula for that? Okay, let me take this one by one here itself. So if roots are real and distinct, I can simply say my root 1 will be minus b plus square root of d upon 2a, whereas root 2 will be minus b minus square root of d upon 2a. Okay, I'm going a bit fast so that I don't have a very big video getting created. You can very well slow down the speed, understand, you can pause it, you can take it down. All these things can be done. So root 1, root 2. That is how we can have these two roots in the first case. Okay, let's move on to the next one. So if the value of d is less than 0, then the roots are complex. That means real part and imaginary part. And they are complex conjugate of each other. So what do? I create, let's say, real part as x1, which is minus b upon 2a, and x2, which is a imaginary part. Now understand d is already negative, so I keep root of minus 1 outside, which will be taken as I. So inside it will be root of minus d upon t, 2a. Real part, imaginary part. So my root 1 is going to be x1 plus x2 and I. That will be printed. I will be only printed. You cannot store root of minus 1 in your computer system. So we have to create that illusion that it's a complex number. Now imagine that x2 might be negative because of this a ka value. A could be negative. So it could be minus value here. But roots are complex conjugates. So second one has to be x1 minus x2i. So imagine if my x1 is 2, x2 is 5, then it is fine. I can have 2 plus 5i and 2 minus 5i. Okay, that is a perfect thing. But suppose my x is 2 and x1 is 2 and x2 is minus 5, then it will get printed as 2 plus minus 5i, 2 minus minus 5i, which are actually happens to be the same. So if you have understood by all this discussion, there is no need of x2 being negative. I only want to snatch the value because anyways I am printing them as positive as well as negative. So that's the reason you can use the absolute function here. Fabs is a function which you will see me doing that in the program. So if you see this video prior to that implementation, you will not wonder why I have used fabs over there. Okay, for this particular reason. If you haven't understood what I explained, do let me know in the comment box. I would rather put more efforts to explain you over there. Okay, so this is the second case where if d is less than 0, the roots are going to be complex and complex conjugate of each other. So I actually calculate the real part and imaginary part separately and I design my roots like this. The third case is very simple. Here though I am writing it as d equal to 0. In the logic, in the implementation, I don't have to write that because if the first two are false and I'm in the else part, automatically it says d equal to 0. Then in that case, roots are real and equal because d part is not there itself. So I would have a simple single root and that will be minus b upon 2a. I don't need to print them as root 1, root 2 separately twice. I'll simply print it as root because the message tells us real and equal. So we have only a single root. Okay, so this was my sincere efforts for making the things easy for you as far as the quadratic equation is concerned. So if you see this video properly, follow this properly, then the next video which we would be having, that is implementation of a quadratic equation, solving quadratic equation rather using a C program, would be really very easy for all of you. Okay, so that's it for the current video. Thank you and a very happy learning.